Let's get through this then today.
Pre-calculus honors. Hi, Danny.
I missed you. Please come back.
Hey.
Okay. All right. Okay, so to graph, we're going to graph polar equations today. Polar equations are going to be written in the form of r equals a function of theta, okay? And what we want to do is, I like to make a table of values to find r values corresponding to different values of theta on 0 to 2 pi. So remember that one cycle, we're looking at sine and cosine, and one cycle for the sine and cosine is over a period of 2 pi. So we go, we take strategic points of theta, we take strategic values of theta, and we want to find the corresponding values of r, okay? All right, so here we have r equals 3 cosine theta, and if this is my coordinate, my grid, it goes from 0 to 2 pi, and I'm going to take basically the special angles that are the same on the unit circle, right? So I have a table of values from 0 to 2 pi, and all I'm going to do is plug in my values, and we're going to round to the nearest tenth, okay? So the first one, when you have 3 times cosine of 0, what does that give you?
That's 3.
3. Because cosine of 0 is 1. Okay? So this is 3 cosine 0 is equal to 1. Okay. So then we have 3 times the cosine of pi over 6. And, I'm sorry, 3. So the cosine of pi over 6, remember, is 3 over... So you're going to plug them into your calculator. So take out your calculators, and we want the correct values of these. Okay, hang on. Okay. Okay, so all right. So what we're doing is we're going to plug in the pi over 6. It'll be 3 cosine of pi over 6. Cosine of pi over 6 is root 3 over 2 times 3. But I want to convert to a decimal because that's going to help me to graph. I want decimal values to know what my radius is going to be. So what is 3 times root 3 over 2? So it's about 3. Okay, so here's, just the first quadrant. Now, if you have cosine of 2 pi over 3, how much is that? What's cosine of 2 pi over 3? What's cosine of 2 pi over 3? Negative 1/2, right? Okay, so because it's over 3, the cosine is going to be the same as this over 3. It's going to be a half. The only thing you have to fix is the negative. So all the over 3's then are going to be 3 over 2, 3 over 2. Okay, I'm going to fix the negatives in a minute. And 3 over 2. And then you have to fix your negatives, right? So 2 pi over 3 is, where is 2 pi over 3? It's in quadrant number 2. The cosine there is negative. And the cosine for 4 pi over 3 is, and here it's positive, all right? So that's how we're going to do it. Now, all the pi over 6's are going to be this same thing, 2.6. 2.6, 2.6. Now, the sign is negative in quadrants 3 and 4, so 7 pi over 6 and 11 pi over 6 are going to have negatives in front of them. All of the pi over 2's are going to be zeros. And then the pi's are going to be what? Cosine of pi is -1, so this is -3, and the other one at 2 pi is 3. All right, so once you fill this out, what we're going to do next is graph, okay? So when theta is 0, r is 3. At theta equals 0, r is 3. 1, 2, 3. Okay? At theta is pi over 6, we're at 2.6, so a little bit down here. At theta equals pi over 3, we're at 1.5, just a little bit more. And then at pi over 2, it's 0. And then at 2 pi over 3, it's -½ So where is 2 pi over 3? 2 pi over 3 is here. -1½ means I am here. I went too far. Here, right? Did I do these wrong? Just the pi over 3. It's supposed to be 1.5. And then at 5 pi over 6, it should be -2.6, right? So at 5 pi over 6, -2.6, which is here, 2.6. And then, what was it at pi? It was supposed to be -3. So at pi is here, -3, we're right there, right? So pi, 1, 2, 3, but you go in the negative direction, which is right there. And now, what about for the next one? At 7 pi over 6, I'm here, it's -2.6, which is where? That point exactly. And so, yeah, it's already done, okay? At 4 pi over 3, we're here. It's -1.5, so we're going to go in this direction. That's already done as well. Because this is symmetric, okay? It repeats itself, and we already went through the entire cycle. So this is my graph. It looks like this, okay? Yes? Woohoo. All right. So we finally got one. All right. So just like in any graph, in any grid, we have a all right, so just like in any graph, we have symmetry in the realm of polar graphs as well, all right? So we have 3 types of symmetry. One is you can have symmetry with respect to the line theta equals pi over 2, all right? And theta equals pi over 2, that's this line here. So look at this. This graph is symmetric around that vertical line, theta equals pi over 2. Another type of symmetry is symmetry with respect to the polar axis. And remember, the polar axis is this. So this has symmetry around the polar axis. So if you fold it along the polar axis, it's symmetric. And then we have symmetry with respect to the pole. That's like, being symmetric to the origin, okay? Where there is a horizontal and a vertical reflection, okay? Okay. Now, here are some tricks of the trade. If an equation is symmetric with respect to theta equals a half, I'm sorry, that should say pi over 2. So if it's symmetric with respect to theta equals pi over 2, here, then we choose values between negative pi over 2 and pi over 2. So do you see how in the example above, we could have just done away with the second half of the table here, right? Because it just repeated itself. Well, it's the same thing in the other situations where if it's symmetric with respect to theta equals pi over 2, all you would have to do is choose values from negative pi over 2 to pi over 2 because the left side is just totally symmetric. Then you just like repeat, okay? You just mirror. If it's symmetric with respect to the polar axis, like this one, you choose values from 0 to pi. So just those values, and then you would just complete the mirror image on the bottom. Okay? How would you know if it is symmetric?
I mean, just looking at the sign.
Right.
This one, how would you know if it's...
So here it is. Okay? Always a step ahead of you. Right? Yeah. Okay. So we can test algebraic equations for symmetry, right? How did we test algebraic equations for symmetry? Well, if it's symmetric, for symmetry around the y-axis, we replace x with negative x. Symmetry with respect to the x-axis, we replace y with negative y, and so on. Similarly, there are quick tests for symmetry of polar equations. All right. So to test for symmetry with respect to the polar axis, you switch theta to negative theta. Okay? And if you get the same equation back, then it's symmetric with respect to the polar axis. So what type of function would give you that symmetry where switching from theta to negative theta didn't matter? The cosine, right. If you want to test around theta equals pi over 2, you make r and theta negative r, negative theta. And for the pole, you change r to negative r. Okay? All right. So here it says use symmetry to graph 1 minus 3 cosine theta. All right. So let's see. To test around the polar axis. Okay. So let's see. Let's change theta to negative theta. Right, so r equals 1 minus 3 cosine negative theta. This gives me 1 minus 3 cosine theta. I get the same thing back, so it's symmetric around the polar axis. Now, is it going to be symmetric with respect to the pole? If I change r to negative r, am I going to get the same thing back? No. And the same thing with theta equals pi over 2. So this is just symmetric around the polar axis. So what did we say here? If it's symmetric around the polar axis, then we choose values of 0 to pi. Yeah. Symmetric. Yeah. All right. So we choose the values 0 to pi, and we plug in our values. It looks like I missed the 1 minus here. Oh boy. So this is r equals 1 minus 3 cosine theta. All right. So we have 1 minus 3 cosine of 0. What does that give me? Negative 2, right? Okay, so 1 minus 3 cosine of pi over 6. How much is that? Negative 1.6. All right, well, what about the pi over 3? Negative 0.5. What about the pi over 2? That's just a 1. What else? This is 0.5. 2.5. And here? What do we get here? 3.6. And at pi? 4. Okay, so let's graph this. At 0, we're at -2. So here, -1, -2. Okay, remember at 0, we're on the opposite side because it's a negative. At pi over 6, it's -1.6. So this way, -1, -1.6. And then what about at pi over 3? It's -0.5. At pi over 2, we're at 1. At 2 pi over 3, we're at 2.5. 1, 2.5. And then where are we at? 5 pi over 6, 3.6. 5 pi over 6, 3.6. So 1, 2, 3.6. And then at pi, I'm at 4. Okay? So it's exactly like a spiral, right? This is where we started, right? So look. Do you see that? It's a spiral. Okay. So it's a spiral, and now, but we're not done because we have to fill in the opposite sides of this, right? We have to do the mirror image. Remember, we only went from 0 to pi. So we have the other symmetric parts to this, from the pi to the 2 pi. So everything now has to be mirrored across from the, or around the polar axis. All right, so anything that's on the polar axis doesn't get mirrored, right? Because it's right there. So this one gets mirrored up. Okay? This one gets mirrored up. This one goes down. This one goes down. This one here. And that one stays. Okay? So it's gonna look like this. Okay, so that's how the entire image looks. This one is this one is like exactly on the... Okay, so that's what it looks like. Oh, it should be on the 2 pi over 3 one. 2 pi over 3 was 2.5. So here, 1, 2.5. All right? Like that. Okay? So that's what it looks like. All right. So this has a special name. It's called a limicin. All right? Which is formed when a circle rolls around the outside of another circle. Okay? So suppose you had a different circle here, and if that circle rolled around it, like that's what you would get. Okay, you would get a limicin. All right. Now, there are many different types of graphs. So just like in the world of, algebraic functions, right? You've got your square root graphs, and you've got your parabolas, and you've got your cubic graphs, and so on and so forth. So in here you have your various types of graphs. So look, there are circles, and they look like, well, circles. And you get a circle if your equation looks like this. R equals a number cosine theta or a number sine theta. That's the first one we graphed today, remember? Now, if you have a number plus or minus cosine theta, just like the one we graphed now, that was a number minus 3 cosine theta, you get one of these. Or a number plus or minus sine theta. You can get these cute little roses if R is A cosine theta or R is A sine theta. Okay? So now when you get these, you get what we call petals. The rose has n petals if n is odd, 2n petals if n is even. All right? So for example, if you have like r equals sine 2 theta, how many petals? 4 petals. If r equals sine 3 theta, how many petals? 3 petals. So if it's odd, it's the same number as this. If it's even, it's twice that. Okay? You do. Because here's what you need to know. Here are the things you need to know. So if I give you a graph, you should be able to come up with an equation. Okay? So for example, like for these, you look at, like if it has like 6 petals, then what would the equation look like? It's sine of, if it has 6 petals, well, I guess it can't have 6 petals. It could have 8. If it had 8, okay?
I was going to say,
yeah.
You're hurting my brain. I thought I got it.
Yeah. And now, the number in front, the A, that's the radius. Okay? Like that's how far out the maximum number goes. So A is the maximum distance, A. Okay. Now, we have what, okay, so look, we have lemniscates, which look like, you know, a figure 8. Lemniscate. And there was even a
they really have to put
pronunciation. Well, you know, for
Archimedes.
And yeah, and the spirals of Archimedes, those are just literally spirals. But, you know, like that's how you graph them. It's A theta plus B. So basically, what are you doing? Look at that. It's R equals A theta. So R is increasing as theta increases. So as your theta increases, you're getting farther and farther away, right? So if you're at 0 theta, you're close. If you're at 20 theta, you're here. If your theta is 400, then you're way out. And then so as your angle gets bigger, you get further and further and further away from the origin. Okay? That's kind of cool, actually. Yeah. All right, so let's graph this one. So we have R equals cosine 5 theta, which, what type of symmetry does this have? Symmetry? It's around the polar axis, which means we're going to graph from 0 to 2 pi. So go ahead and take a few minutes and graph this one. When you complete your table, this is what it should look like. Now, I've started to put 2 of the points on here. So keep track of which one you put first and which one you put second. So this is cosine of 0 equals 1. That's the first point. And then cosine of pi over 6 is, that's aligned differently. So cosine of pi over 6 is negative 0.87. So it's pretty much here. On the 0. I mean, on like close to that O. Cosine of pi over 3, and that's point number 2. Cosine of pi over 3 is 0.5, which is there. That's the third one that we put up. And then cosine of pi over 2 is 0. Cosine of pi over 2 is 0. So what happened here? I went around like this, and I came back. Okay, yeah. Well, not yet. Yeah. And then cosine of 2 pi over 3 is negative 0.5, which is here. So that's my 5th point. Cosine of 5 pi over 6 is 0.87. Here. Why don't we make each of them half? So let's calibrate so we open it up a little bit. Okay? Let's make each of them a half so you guys could see it better. So look, let's make this a 1 here. right? So this will be the 0.5, okay? So that's your first point. And then make the pi over 6 negative 0.87 here. And then, so that's your second point. And then the pi over 3 is 0.5. The pi over 2 is 0. That's my fourth point. 2 pi over 3 is negative 0.5. 5 pi over 6 is 0.87. Here. And pi is negative 1, which is there. Right? So how does that look?
What number is that on the bottom left?
2.
It's like double added.
Yeah.
Wait, you skipped number 6.
Hang on. Let me erase this one. I didn't. It's over there.
Oh, it's like a loopy.
Yeah. All right, so talking about maximum R value. The maximum R value is the furthest point that the graph reaches from the pole, right? So it's the furthest point that you get from the origin. Now to find this, you have to find the values of theta for which R is a maximum, and we don't want just R, we want the absolute value of R. So if R is 0 for a certain value of theta, it means it's intersecting the pole at that point. So look at this here. R squared is equal to 8 sine 2 theta. Now it says identify the type of curve, then determine the symmetry, the zeros, and the maximum R values. So what type of curve is this? If we go, so this is 8 sine 2 theta, and if we go to our table here, what kind of curve is that one? It's 8 sine 2 theta, so which one is it? It's a rose, okay? It's a rose.
But it's also
Remember, this is a squared cosine 2 theta, so it's a rose. Huh? So,
because the R squared just makes it symmetrical on the pole.
okay, so now what we're going to do is this. Let's talk about the symmetry. I don't know what's going on here. All right, so let's talk about symmetry. All right, so to check if it's symmetric around the polar axis, what would we do? Change theta into negative theta. So this is going to be R squared equals 8 sine 2 theta. Does that work? 2 negative theta, sorry.
No.
So, no. What about...
Yeah, it's square.
Right, so if we change R to negative R, what are we testing for?
Around the pole.
Around?
No, it's around that.
Around theta equals pi over 2.
Yeah,
Right?
No,
Theta
it's
equals
around the pole.
theta equals pi over 2.
That would be if you were also.
Oh, sorry.
That would be if that was cosine.
Yeah.
to your face.
Sorry, yes. So, pole R to negative r, so we get negative r squared is equal to 8 sine 2 theta, so that works. Okay, so it's symmetrical around the pole. Now, what about the zeros? Now, this is a sine graph, right? Where is sine equal to 0? At 0 and pi and 2 pi, right? So 2 theta is equal to 0, 2 theta is equal to pi, 2 theta is equal to 2 pi. That means theta is equal to 0, pi over 2, and pi. Okay? Yeah, so this function is 8 sine 2 theta. Now, sine is 0 at 0 and pi and 2 pi. So for this function, the argument of the sine, the 2 theta must equal 0, or the 2 theta must equal pi, or the 2 theta must equal 2 pi. And if you solve that, these are the values where it equals 0. Now, what about the maximum r values? What is the maximum value of the sine? 1, right? Or in this case, it's 8. So, where is sine maximum? Where is sine equal to 1? Pi over 2 and 3 pi over 2. Okay, so maximum r values. It's absolute value. Okay? So, sine of theta is equal to 1 or minus 1 at theta equals pi over 2 and 3 pi over 2. So now you plug those into your r. So in this case, r squared is 8 sine 2 theta, and you want your maximum r values. So r squared is equal to 8 sine 2 pi over 2, right? So r squared is equal to 8 sine pi. That means, what's sine of pi? No, hang on. Sorry. No. Okay, so it's when 2 theta is pi over 2. It's when 2 theta is pi over 2. Right? It's when the argument is pi over 2. So I want 8 sine pi over 2, which is what? R is equal to what then? R is equal to 8. Okay, so those are the maximum R values. R is equal to 8. Root 8. Not feeling. Sorry. Okay? Alright. To graph, let me show you how to graph on the calculator. Who is?
I don't get what you're doing.
Okay, so what I want is sine has a maximum of 1 or minus 1, right? Well, sine goes from 1 to negative 1, always, okay? All right, when does that happen? When the argument of the sine is either pi over 2, when the argument of the sine is either, right, pi over 2 or 3 pi over 2, right? Okay, so here we say, all right, then r squared is 8 sine pi over 2, which means, what is this? R squared is equal to 8, because sine of pi over 2 is 1. So r then is the square root of 8. Okay. Now let me show you how to graph this on the calculator. On the calculator, you're going to go to mode, and you're going to change here. Yours is on function. You're going to go to the right twice and switch to polar. Enter. When you do that, when you go to y equals, then you've got your r. And so we're going to type in, what was this one?
8 sine squared
Well, this is the square root.
Of 8 sine 2 theta.
It's the square root of 8 sine 2. Now look, this one, you've been using it as x, but all this time it's got a t and a theta and an n next to it, and you never even knew why. Well, this is why, because that button is just the all-purpose variable button, okay? But we also need the negative of this, right? Because r is the plus or minus, so it's 8 sine 2 theta. Now, we're going to graph. So let's do zoom 6 for a minute. And that gives you a tiny little graph here. If you go into your window, so you're still graphing in like in X and Y, you know, in Cartesian. So it's sort of like morphing two graphs. So if you go here to your X min, and let's say if we go from, what was the maximum R value? Was the square root of 8. So if we go to like -5 to 5, we're not clicking zoom in. I get it. I get it. So -5 to 5, and then here we're going to go from -5 to 5. And now graph. That's what it looks like. Okay? So now, if you use your calculator to graph, then fine. I will allow you to use your calculator to graph. However, all of this, you should be able to do this without a calculator. So I can very easily give you all of this with no calculator, and you should be able to do it. You should not have to rely on your calculator for this part, but when it comes to the actual graph, you can use your calculator. Okay? All right, so this homework is due tomorrow, Friday.